See from the beginning. See this is the case of the lift. Okay, a person stands in the lift and he goes to the 10th floor, and no one is he hasn't stopped the lift in between, or no one has stopped the lift in between. So now there's a ground floor. He gets into the lift, then it goes to the 10th floor. So what exactly happens? Maybe up to second floor, maybe approximately I'm saying, maybe it can be first floor also, it can be second floor. So second floor, up to second floor, it accelerates. So accelerates, and m equal to what? No. So what happens here? It accelerates, then it will go with the uniform velocity, then it will go to the, then it will start decelerating. Okay. So now when the body here in this case, now here where W equal to mg is acting downwards, tension is upwards. Here it is accelerating. So T minus mg equal to ma, T equal to mg plus ma. Take m common, m into g plus a. Here velocity is constant, acceleration is 0. So T equal to mg. Next is what? Here T is going, that is in this third case, what will happen? It is decelerating. So the weight is acting downwards, tension is acting upwards. So T minus mg is equal to minus ma. So T equal to mg minus ma, m into g minus a. Okay. So this is the situation. So what will happen? In the beginning, from ground floor to second floor, the person will feel heavy, and from second floor to 8th floor, the person will feel the same weight, and from 8th floor to 10th floor, the person will feel less than her or his own weight. Now suppose if at all the cord breaks, then what will happen? Free fall. What we say is free fall. Suppose this is mg is acting downwards, tension T is acting upwards, and then here gravity. So what will happen? Mg minus T equal to mg again. Okay, this and this will go away. So T is equal to 0. So this is a free fall. So mg minus T is mg minus T is equal to ma. So that means the person will feel a free fall. Okay, clear? Copy this one, then we'll go ahead. Here, there are in the monkey numerical, the monkey jumps onto the rope. The rope is hanging and he jumps on the rope. Then mass of the monkey is 40 kg, and tension the rope can withstand, maximum tension with which it can withstand is 600 newtons. So when it is going up, now there are 4 cases. What happens when it is going with an acceleration 6 meters per second square? What happens when it is going down and going up with a uniform velocity? Acceleration equal to g. Now, here the first case, what will happen? In the first case, what will happen here? Suppose that it's like a lift problem only, the same like lift. Okay. Now, it is going up with acceleration a equal to 6 meters per second square. Tension is T, and mg is acting downwards. Okay, so what will happen now? So T is equal to T minus mg equal to ma. The first case, T minus mg equal to ma. So T equal to what? T equal to mg plus ma. So T equal to m into g plus a. T is equal to m is 40. 40 into g is 10 plus a. Acceleration is 6. T is equal to 40 into 16. How much it will be? 40 into 16. 64. 640 newtons, right? 640 newtons. So 640 is greater than 600 newtons, right? So what will happen? The rope will break or not?
The rope will break.
Yeah, the rope breaks. Okay, here in this first case, rope breaks. Second one. Here, what will happen? The second case. Now here it is going down with an acceleration. So what will happen here? Here it is, this is a equal This is the acceleration. Mg acting downwards, tension T acting upwards, and here it is going down with an acceleration. Mg minus T equal to Ma. So T is equal to what? Mg minus T equal to Mg minus Ma. T is equal to M into G minus A. T is equal to 40 into 10 minus 4. T is equal to 40 into 6. So 240 newtons. So what will happen? Rope doesn't break. Rope doesn't break. Next case, third one. In third one, what happens? It is going with the uniform velocity upwards. Tension is like this. Mg is acting downwards, going with the uniform velocity v. Acceleration equal to 0. So what will happen? T equal to mg. So T equal to 40 into 10. T is equal to 400 newtons.
400 newtons.
So nothing will happen. And if it is last case, what is that? A equal to G. What should I do? Okay, I'll try here, the last part. So here A equal to G. So that is mg here and tension T here, it is going downwards. So mg minus T is equal to mg. So what will happen? T equal to 0. There is no tension in the rope. Okay. Falls down the rope nearly under gravity. A equal to G. So these are the 4 cases. Okay. In the long problem. Okay. Long roller. So no, long roller generally is used in the stadium or on the ground to flatten the surface, to make the surface. So for that purpose we use. Now suppose push and pull. Suppose this is the long roller and he is applying the force like this. And the second case is pull. Okay, you know push and pull, right? On the door it is there. Push and pull. So this is he's applying the force in this way, and the weight W is W equal to mg is acting downwards. Here also weight W equal to mg is acting downwards in both the cases. So what is easier? You will ask, what is easier? Is it easier to push or pull? Let us see. Now the here see the weight W equal to that is, there are two components here. If this is theta, so this will become F cos theta, and this will become F sin theta. Now here also this is what if this is theta, this is force, F cos theta, this is F sin theta. F sin theta. Okay, so what will happen here? And this is the friction. Suppose think that this is the friction, and here when it is going forward, that is, this is moving forward. So this is the frictional force. It's going in this way. Okay, so what will happen now? Now look at the forces. This is a free body diagram. So both the forces F sin theta, downward force F sin theta plus mg, both are acting downwards. F sin theta and mg both are acting downwards. And vertical horizontal forces F cos theta minus F equal to mn. Whereas looking if you look at this situation, downwards, the vertical forces. So what happens? F sin theta equal to mg. And horizontal force F cos theta equal to minus F is equal to mn. So if you look at the downward force, F sin theta is added with the weight of the long roller. F sin theta is added to the weight of the long roller. But here it is not like that. So what do you think now? This is push and this is pull. Which is easier now? Is it easier to pull or push? Look at the components. F sin theta and mg, both the forces are acting downwards. Will it increase the weight or decrease the weight?
Increase.
Will it increase the weight or decrease the weight? Girls. Weight is added with F sin theta. Will it increase or decrease?
Sir, increase?
Increase. Yeah, very good. It increases. But here, will it increase? in this case?
No.
No, the upward force and downward force are equally distributed. So what is easier now? The second one is same, no change. The horizontal, no change. But vertical, it is more. Downward force is more than. But here it is not like that. So what do you think? Is it easier to push or pull?
Pull.
Yeah. No one is saying anything. Is it easier to push or pull now?
So they said pull.
Pull, very good. Yeah. So pulling is easier than pushing. Okay. So you can write down. Okay. So it is easier to pull than push. Okay. Clear? So this is one more numerical.